At first glance, a bee looks small, almost insignificant. It weighs less than a paperclip. It can fit on the tip of a finger. Most people notice bees only when they buzz too close, when they land on a drink, or when they sting in self-defense. But beneath that small body is one of the most important forces shaping life on Earth. Long before humans built cities, long before farms, long before recorded history, bees were already working, quietly, constantly, without rest. Bees are not here by accident. They are part of a system that took tens of millions of years to form. Flowers did not always exist. Fruits did not always exist. Many of the foods humans now depend on were shaped by an ancient partnership between plants and insects. Among all insects, bees became the most precise, the most reliable, and the most devoted partners plants ever had. A bee does not wake up and decide to help the planet. It does not understand agriculture, ecosystems, or humans. A bee follows instinct. It follows scent, color, light, and memory. Yet by doing so, it moves life forward in a way no machine, no technology, and no human plan has ever fully replaced. When a bee flies from flower to flower, it is not just collecting nectar. It is transferring pollen, microscopic grains that carry the genetic code of plants. This transfer allows plants to reproduce. Without it, many plants would fail to make seeds, fruits, or new generations. This single act, repeated billions of times every day across the planet, is called pollination. Pollination is not optional for life as we know it. It is foundational. Roughly 1 out of every 3 bites of food humans eat exists because of pollinators, and bees are responsible for the majority of that work. Apples, almonds, blueberries, strawberries, cherries, cucumbers, avocados, coffee, cocoa, and countless other crops rely on bees to exist at scale. Without bees, grocery stores would not look empty. They would look unrecognizable. But the story of bees is not only about food, it is about balance. Wild plants depend on bees just as much as crops do. Forests, grasslands, and meadows all rely on pollination to maintain diversity. When bees disappear from an area, plant diversity shrinks. When plant diversity shrinks, insects disappear. When insects disappear, birds leave. When birds leave, predators struggle. The collapse moves upward, layer by layer, like a tower losing its foundation. Bees are ecosystem engineers. They shape landscapes without digging, cutting, or building. They do it through movement, through repetition, through loyalty to routine. A single honeybee may visit thousands of flowers in a day. Over its short life, it may visit tens of thousands. Multiply that by millions of bees in a single colony, and then multiply again by the countless colonies spread across the planet. What seems small becomes enormous. Humans have lived alongside bees for thousands of years. Ancient civilizations respected them, feared them, and admired them. Honey was one of the first sweeteners humans ever knew. It did not spoil. It healed wounds. It preserved food. Beeswax lit homes and temples. In many cultures, bees symbolized order, hard work, and cooperation. Even today, humans still use the language of bees. We talk about hives, workers, queens, and busy schedules without stopping to think where those ideas came from. A bee colony is not chaos. It is one of the most organized systems in nature. Each bee has a role. Worker bees clean, feed larvae, build wax cells, guard entrances, and forage for food. The queen does not rule. She does not give orders. Her role is reproduction. The health of the colony depends on the coordination of thousands of individuals responding to chemical signals and shared behavior. No bee sees the whole picture, yet the system works. This is where the story becomes unsettling. In recent decades, scientists, farmers, and beekeepers began noticing something wrong. Hives that were once full of life became quiet. Adult bees vanished, leaving behind queens, food, and young bees that could not survive on their own. This phenomenon became known as colony collapse. It was not a single event. It was not limited to one country. It appeared across continents. At first, there was confusion, then concern, then alarm. Why were bees disappearing? The answers were not simple, because the problem was not simple. Bees face pressure from many directions at once. Modern pesticides interfere with their nervous systems, making it harder for them to navigate, learn, and return home. Habitat loss removes the wildflowers they evolved to depend on. Industrial farming creates vast fields of single crops that bloom briefly and then become food deserts. Parasites weaken colonies from the inside. Climate change shifts flowering times, separating bees from the plants they rely on. Each problem alone is stressful. Together, they are overwhelming. Bees evolved in a world of diversity, not uniformity. They evolved alongside changing seasons, but not seasons that arrive too early or too late. They evolved alongside predators, but not chemical exposure designed to kill insects. The modern world moved faster than bees could adapt. The danger is not just that bees might disappear. The danger is that their disappearance would not be loud. It would not happen all at once. It would happen quietly, region by region, crop by crop, season by season. A failed harvest here, a struggling orchard there, higher food prices, fewer choices, increased hunger in vulnerable populations. Nature does not collapse like a movie explosion. It unravels. If bees vanished completely, many plants would follow within years. Some could be pollinated by wind or other insects, but many could not. Entire food chains would be disrupted. Livestock would suffer as forage plants declined. Human diets would become less nutritious and more limited. The world would still exist, but it would be poorer, less stable, and far more fragile. This is why people are talking about bees. Not because they are cute, not because they make honey, but because they reveal how connected everything truly is. Bees are a test, a signal, a warning light on the dashboard of the planet. When they struggle, it means the system itself is under strain. Yet this is not only a story of loss, it is also a story of attention, of awareness, of change that is still possible. People are planting wildflowers again. Farmers are rethinking practices. Cities are building pollinator corridors. Scientists are studying bee behavior with new respect. Children are learning that fear should not replace understanding. Every small action matters, because bees themselves prove that small actions repeated endlessly can shape the world. A bee does not know it is important. It does not know humans are watching. It does not know its survival has become a global conversation. It simply flies, lands, collects, and moves on. And in doing so, it holds together the living fabric of Earth. The question is no longer whether bees need us. The real question is whether we are wise enough to need them. To understand why bees matter so much, it helps to understand how they experience the world. A bee does not see reality the way humans do. Its vision is tuned to ultraviolet light, a spectrum invisible to human eyes. Flowers are not just colorful shapes to a bee. They are glowing maps. Nectar guides appear like landing lights on a runway, directing bees exactly where to go. What looks ordinary to us is, to a bee, a carefully designed invitation. A bee's brain is small, smaller than a grain of rice, yet it is powerful in ways that challenge assumptions about intelligence. Bees can learn patterns. They can recognize faces. They can count. They can remember locations over long distances. They can solve simple problems and even show signs of emotional states, becoming more pessimistic after stress. Intelligence, it turns out, is not about size. It's about efficiency. When a bee finds a rich source of nectar, it does something extraordinary. It returns to the hive and performs a movement known as the waggle dance. This is not random motion. It is a precise form of communication. The angle of the dance shows the direction of the food relative to the sun. The duration shows distance. The intensity signals quality. In darkness, surrounded by thousands of other bees, this dance allows information to spread through the colony. It is one of the clearest examples of symbolic communication outside the human world. This communication allows bees to act as a single organism made of many bodies. Decisions are not made by a leader, but by consensus. When a hive needs a new home, scout bees search for options. They return and advertise locations through dance. Other bees inspect those sites. Over time, support gathers around the best choice. Eventually, the colony moves together. No arguments, no confusion, just alignment. Bees are not just workers, they are planners. Their bodies are also specialized tools. Tiny hairs cover a bee's body, each one designed to trap pollen grains through static electricity. As a bee flies, friction builds a charge. When it lands on a flower, pollen jumps onto its body as if pulled by an invisible force. Nature engineered a living magnet. Inside the hive, bees transform nectar into honey through evaporation and enzymes. They fan their wings to control humidity. They seal honey in wax cells for long-term storage. Honey is not just food, it is survival. It allows the colony to live through winter when flowers disappear. Few animals on Earth create food that never spoils. Bees do. The structure of the honeycomb itself is a marvel. Hexagons form because they are the most efficient shape for storing material with minimal waste. Bees did not study geometry, yet they mastered it. The hive is strong, lightweight, and adaptable. It expands and contracts with the needs of the colony. It is architecture born from instinct, refined by time. For millions of years, this system worked. Bees thrived without human interference. Then, agriculture changed everything. At first, farming helped bees. Fields of crops meant fields of flowers. Bees had food, and humans had harvests. But as farming became industrialized, diversity disappeared. Fields became larger. Crops became uniform. Pesticides became common. What once supported bees now often harms them. Modern pesticides are not always designed to kill bees outright. Many are designed to confuse insects, to disrupt feeding, to interfere with reproduction, to impair navigation. A bee exposed to these chemicals may leave the hive and never return, not because it died immediately, but because it forgot how to find home. Bees also face invisible enemies. Parasites like the varroa mite attach to their bodies, weakening them and spreading viruses. These mites reproduce quickly and are difficult to control. A single infested hive can collapse within months. In the wild, bees had ways to manage such threats. In modern environments, stress makes them vulnerable. Climate change adds another layer of uncertainty. Flowers bloom earlier or later than expected. Rain patterns shift. Heat waves strain colonies. Bees time their life cycles to the rhythm of the seasons. When that rhythm breaks, survival becomes a gamble. This is why bee decline is not just an environmental issue. It is a systems issue. It reflects how food is grown, how land is used, how chemicals are regulated, and how humans value short-term efficiency over long-term stability. Despite this, bees persist. They adapt when given space. They rebound when habitats are restored. Wild bees return when lawns become meadows. Cities, surprisingly, can be havens. Rooftop gardens, parks, and diverse plantings often support more pollinators than monoculture farms. Life finds opportunity wherever humans allow complexity to return. There are more than 20,000 species of bees on Earth. Not all live in hives. Many are solitary. Some nest in soil, some in wood. Some are active for only a few weeks each year. Honeybees are only one part of a much larger story. Protecting bees means protecting diversity itself. What makes this story urgent is not that bees are weak, it is that they are honest. They respond quickly to change. They show the consequences of human choices without filters or delays. When bees struggle, it is because the environment is struggling. The fate of bees is not sealed. It is still being written. Every flower planted, every chemical reduced, every habitat preserved. These actions ripple outward. Bees do not ask for gratitude. They do not demand recognition. They only require space to do what they have always done. And if they are allowed to continue, quietly moving pollen from flower to flower, they will keep supporting a world that often forgets how much it depends on the smallest workers of all. Imagine a world where the buzzing grows quieter each year. Not suddenly, not dramatically, just enough that people barely notice. A spring with fewer blossoms, a summer with fewer fruits, a fall where harvests come in lighter than expected. At first, these changes feel like coincidences, bad weather, market fluctuations, temporary shortages. Humans are very good at explaining away slow disasters, but nature keeps its own records. When bees disappear from an ecosystem, plants that depend on them begin to fail in subtle ways. Flowers still bloom, but fewer turn into fruit. Seeds become weaker. Genetic diversity shrinks. Plants become more vulnerable to disease and drought. Over time, entire species fade out, not with extinction headlines, but with silence. This loss does not stay in the fields. It moves into forests, into grasslands, into riverbanks and mountains. Birds that feed on insects lose food. Mammals that rely on fruits struggle. Predators lose prey. The web tightens, then snaps at its weakest points. Humans feel the impact differently. Food becomes more expensive. Nutrition declines. Diets become narrower. Staples replace variety. Fresh produce becomes a luxury instead of a given. Regions that already face food insecurity are hit first and hardest. Global inequality deepens, not because of politics alone, but because biology has limits. Technology tries to step in. In some places, humans already pollinate by hand. Workers climb ladders with brushes, transferring pollen flower by flower. It is slow. It is expensive. It is impossible to scale globally. Machines are tested. Drones are designed. None come close to matching the efficiency, adaptability, and self-repair of a living bee. A bee is not just a pollinator. It is a decision maker. It chooses which flowers are worth visiting. It responds to weather. It adapts routes. It works for free, powered by sunlight transformed into sugar. Replacing that system would require energy, infrastructure, and coordination beyond anything currently possible. This is why bees are often described as irreplaceable, not because humans lack creativity, but because nature solved this problem long before humans existed. Yet there is another future. In this future, humans listen. Cities stop treating nature as decoration and start treating it as infrastructure. Roads are lined with flowering plants. Parks are designed for biodiversity, not just aesthetics. Lawns shrink, meadows grow. Children grow up seeing bees not as threats, but as neighbors. Farms diversify, crop rotation returns, hedgerows come back, flowers are planted between fields, chemicals are used carefully or replaced entirely, soil becomes alive again, pollinators return, yields stabilize, not through force, but through balance. In this future, beekeepers are not just honey producers, they are stewards. Scientists work with farmers. Indigenous knowledge is respected. Traditional practices blend with modern research. Solutions are local, flexible, and resilient. Education changes too. People learn that fear of insects is learned, not natural, that most bees do not sting, that a bee sting is a last defense, not an attack. Understanding replaces panic. Curiosity replaces fear. This future is not unrealistic. Pieces of it already exist. Wherever humans choose complexity over convenience, bees respond. Wherever flowers return, bees follow. Wherever ecosystems are allowed to breathe, life accelerates. The bee becomes a symbol, not of fragility, but of responsibility. A reminder that power does not always roar. Sometimes it hums. There is something humbling about realizing that human survival is tied to the flight path of an insect. It challenges the idea of dominance. It reframes progress. It forces a quieter question. Not what can we control, but what can we sustain? Bees do not need humans to survive everywhere, but humans need bees to thrive anywhere. Their story stretches backward through deep time and forward into uncertain futures. It is written in pollen, in petals, in fruit, in fields. It is written in the choices made every day, often without thought. If bees vanish, it will not be because they failed. It will be because we did. And if they endure, it will not be because of a single invention or policy, but because enough people decided that a living world is worth protecting, even when the heroes are small, striped, and easily overlooked. The next time you see a bee resting on a flower, wings dusted with gold, consider the scale of what you are witnessing. A worker on a mission older than humanity, a link in a chain that feeds forests, animals, and people. A quiet promise that life, when given the chance, knows exactly how to continue. Bees also teach something uncomfortable about time. Humans think in years, quarters, and lifetimes. Bees think in seasons, moments, and cycles. A worker bee may live only a few weeks during peak season. Everything it does is urgent. Every flight matters. There is no long-term plan for the individual, only continuity for the whole. This mindset shaped how bees evolved. They do not waste energy. They do not hoard more than needed. They do not take without giving something back. Nectar becomes honey. Pollination becomes life. Even death serves a function. As nutrients return to the system, nothing is extra. Modern human systems often operate in the opposite way. Extraction without regeneration. speed without recovery, growth without balance. These reveal the cost of that difference, not through protest, but through absence. Another overlooked truth is that bees are indicators of environmental health. Scientists call them bioindicators. When bees thrive, it usually means soil is healthy, water is clean, and plant diversity is strong. When bees decline, it is rarely just about bees. It is about the entire environment failing quietly in the background. This is why monitoring bee populations helps predict larger ecological shifts. A drop in bees often precedes declines in other insects. Those declines then affect birds, amphibians, and small mammals. By the time humans notice a crisis, bees often noticed it first. There is also a social lesson hidden inside the hive. A bee colony values cooperation over competition. There is no reward for individual dominance. No bee gains power by taking more. Survival depends on synchronization. When a colony weakens, stronger bees do not abandon it. They work harder. When resources are scarce, behavior changes collectively. This is not idealism. It is necessity. Nature does not reward selfishness at the scale of ecosystems. It rewards systems that can sustain pressure without breaking. Even conflict in a hive is regulated. When queens compete, it is not endless war. It is brief, decisive, and resolved. Once the colony stabilizes, energy returns to survival. There is no lingering chaos. Nature does not have the luxury of inefficiency. Bees also challenge human assumptions about beauty and fear. Their warning colors signal danger, yet they are also pollinators of the most beautiful flowers. They sting, yet they heal. Honey has antibacterial properties. Propolis, a resin bees collect, is used to seal cracks and protect the hive from infection. It has been used by humans for medicine since ancient times. Bees do not separate danger from benefit. They embody both. This duality is part of why they are misunderstood. Fear of stings overshadows understanding of behavior. Most bees sting only when threatened or crushed. Many species cannot sting at all. The fear response is often learned, passed down, exaggerated. Relearning coexistence requires patience. It requires slowing down, watching, listening, not swatting at every movement. Bees respond to calm. They sense vibration. Aggression invites defense. Respect invites indifference. In many traditional cultures, bees were spoken to. Hives were informed of deaths and births. This was not superstition alone. It was recognition, acknowledgement of shared space. Modern life rarely allows that intimacy with nature. Yet the consequences of losing it are becoming harder to ignore. Urbanization does not have to mean separation. Bees adapt well to cities when given resources. They nest in walls, roofs, and planters. They forage in parks and balconies. Some urban areas now host more diverse bee populations than rural farmland. This is not because cities are better, but because diversity still exists there. The lesson is not that humans must abandon development, but that design matters. Systems can either erase life or make room for it. Bees also remind us that resilience is not strength alone, it is redundancy. Many species doing similar jobs in slightly different ways. When one fails, another steps in. Monocultures collapse because they lack backup. Diversity absorbs shock. This applies to ecosystems, economies, and societies alike. When humans simplified landscapes, they removed that redundancy. Bees became fewer, more stressed, more dependent on fragile systems. Restoring resilience means restoring options. Even now, scientists discover new bee species. Entire populations exist unnoticed, doing essential work without names or studies. Life continues beyond human attention. That humility matters. The bee story is not a warning shouted from the future. It is a quiet report from the present, a steady signal that life depends on relationships, not domination. And those relationships, once broken, take time to heal. Long before bees were studied, measured, and classified, they were observed, watched closely by people who depended on land, seasons, and weather for survival. Early humans did not need scientific instruments to understand bees. They watched where bees went, what bloomed when bees arrived, and what failed when they did not. Ancient rock art shows bees. Early texts mention honey as sacred. In many civilizations, bees were messengers between worlds, symbols of order emerging from chaos. The hive became a model for society itself. Cooperation, duty, balance. In ancient Egypt, bees were associated with royalty and the soul. Honey was offered to gods and placed in tombs. In Greece, philosophers wrote about bees as natural examples of perfect organization. In many parts of Asia, Africa, and the Middle East, beekeeping was passed down as craft, not industry. Knowledge was inherited, not extracted. These societies understood something modern systems often forget. You cannot rush bees. You cannot force honey. You cannot take without consequences. Traditional beekeepers worked with the rhythm of colonies. They took only surplus honey. They respected seasonal limits. They knew that stress weakens bees, and weakened bees mean no honey next year. Sustainability was not a slogan. It was survival. As science advanced, bees became subjects of fascination. Naturalists documented their behavior. Biologists uncovered their communication. Chemists analyzed honey. Ecologists mapped their impact. Every layer revealed complexity that challenged earlier assumptions. The more humans learned, the more they realized how much they still did not know. Even now, bees continue to surprise researchers. They adjust flight paths to wind patterns. They optimize routes like traveling salesmen solving mathematical problems instinctively. They regulate hive temperature with collective movement. They adapt feeding strategies based on nutritional needs, not just availability. Bees are not simple machines. They are living systems responding to feedback. This matters because it exposes a deeper truth. When humans disrupt ecosystems, they are not breaking static objects. They are interfering with adaptive networks. Damage is not always visible immediately. It accumulates. It cascades. This is why the bee crisis took time to be noticed. The system was compensating until it could not anymore. There is also an ethical dimension to the bee story. Humans benefit enormously from bee labor. Yet for much of modern history, that labor was treated as infinite, free, guaranteed. Only when decline became visible did concern rise. This pattern repeats across environmental issues. Action often follows crisis, not foresight. But bees offer a chance to change that pattern because their needs are not abstract. They need flowers, clean environments, diversity, time. These are tangible, achievable, measurable. Protecting bees does not require perfection. It requires intention. It also requires redefining progress. A system that produces high yields while degrading ecosystems is not successful. It is borrowing from the future. Bees reveal the interest on that debt. In education, bees serve as powerful teachers. Children who learn about bees learn systems thinking, cause and effect, interdependence, responsibility. A bee lesson is never just about an insect. It is about how life is connected. Fear fades when understanding grows. Wonder replaces disgust. Respect replaces control. Even in science labs, bees have changed how intelligence is defined. Their problem-solving abilities force a re-evaluation of what cognition looks like. Intelligence is not always centralized. Sometimes it emerges from simple rules repeated collectively. This insight influences fields beyond biology. Robotics, artificial intelligence, economics, network theory. Bees inspire human innovation, even as human innovation threatens bees. There is irony in that. The future relationship between humans and bees will depend on whether humility can keep pace with knowledge. Knowing how bees work is not enough. Choosing to act on that knowledge is the test. Bees do not need speeches. They need landscapes. They need humans to stop thinking of nature as separate, as background, as expendable. Bees wake up with the sun. Light matters to them. Temperature matters. Wind matters. A small change in the air can change an entire day for a hive. When conditions are right, they leave together, not all at once, but in waves. One by one, they exit the hive and scatter across the land, each following a memory, a scent, a pattern learned from yesterday. A bee does not explore randomly. It remembers where food was. It remembers which flowers were worth the energy. It remembers the safest routes. When a place stops providing, the bee stops returning. In this way, bees constantly map the environment, updating their understanding of the world every hour. When bees land on flowers, they are not gentle by accident. Their weight, their movement, their contact with petals, all evolved together with plants. Flowers need disturbance to release pollen. Bees provide that disturbance perfectly. Too much force would damage the flower. Too little would do nothing. Over time, plants that matched bees survived, and bees that matched plants thrived. This partnership shaped landscapes. Fields full of flowers exist because bees made them possible. Trees that produce fruit exist because pollination worked again and again over thousands of generations. Even wild plants humans never eat depend on bees to reproduce. These plants hold soil in place. They control water flow. They prevent erosion. When bees disappear, these quiet services disappear too. Inside the hive, everything is alive with motion. Bees touch each other constantly. Antennae exchange information through scent. Chemical signals tell bees when food is coming in, when danger is near, when the queen is healthy, or when something is wrong. The hive smells different when it is sick. Bees react to that immediately. Young bees start with small tasks, cleaning cells, feeding larvae. As they age, their roles change. They become builders, guards, and finally, foragers. This order is not fixed. If a hive loses foragers, younger bees step up early. If danger increases, more guards appear. Flexibility keeps the colony alive. Bees do not waste energy arguing. They respond. When humans use chemicals in fields, bees carry traces back to the hive. These chemicals do not always kill instantly. Instead, they weaken memory. A bee may forget how to dance correctly. Another may forget how to recognize danger. Larvae may develop slower. Queens may lay fewer eggs. The hive looks normal until it does not. This slow damage is dangerous because it hides itself. Bees also suffer when land becomes empty. Large green fields may look healthy to humans, but to bees, they can be deserts. One type of plant blooming for a short time cannot support a colony for a full season. Bees need variety. Early flowers, mid-season flowers, late flowers. Without that, they starve even while surrounded by green. Wild bees feel this even faster. Many live alone. They do not have stored honey. If flowers disappear for a few weeks, entire local populations can vanish. When that happens, nearby plants lose pollinators. The loss spreads outward quietly. People often think honeybees are the only bees. They are not. Bumblebees, mason bees, leafcutter bees, mining bees, carpenter bees, and thousands more all do different kinds of pollination. Some work in cold weather. Some specialize in one plant. Some vibrate flowers to release pollen that honeybees cannot access. When these bees disappear, honeybees cannot replace them. Bees divide the work of the planet. Weather changes make this harder. Warm winters confuse bees. Early blooms arrive before bees are active. Late frosts kill flowers after bees arrive. Heavy rains wash pollen away. Extreme heat forces bees to stay inside and cool the hive instead of foraging. Each disruption alone is manageable. Together, they overwhelm colonies. Bees do not complain. They simply fail. When bees vanish from an area, humans usually notice years later. By then, recovery is harder. Bees need time to return. Plants need time to regrow. Soil needs time to heal. This delay makes action feel pointless, but it is not. Where flowers return, bees return. Roadside flowers matter. Backyard flowers matter. Balcony plants matter. Small patches connect into networks. Bees move across miles. One safe space can support many hives indirectly. This is how recovery starts, quietly, without announcements. Bees do not need perfection. They need continuity. They have always lived in a changing world. Ice ages came and went. Continents shifted. Forests moved. Bees survive by adapting slowly. The danger now is speed. Change is happening faster than adaptation allows. Bees are not fragile by nature. They are being rushed. Bees begin their lives in darkness. Inside a small cell made of wax, an egg rests, almost weightless. Laid with precision by the queen. The queen does not choose randomly. Each cell has a purpose. Some will hold workers. A few will hold drones. Rarely, under special conditions, a cell will be shaped differently, larger, fed differently, and inside it a future queen will grow. From the moment the egg hatches, care begins. Worker bees feed the larva constantly. The food changes as the larva grows. For most bees, the rich food is temporary. For a queen, it never stops. This single difference determines everything. Same genes, different diet, completely different fate. The queen grows larger, lives longer, and becomes capable of laying thousands of eggs. This is not favoritism. It is function. When a new queen is being raised, the hive is preparing for change. Sometimes it means the old queen is failing. Sometimes it means the colony is strong enough to divide. This process is called swarming. Half the colony leaves with the old queen to find a new home. What looks like chaos in the air is actually order in motion. Swarming is how bees spread. It is how ecosystems get pollinators in new places. When humans fear swarms and destroy them, they interrupt this natural expansion. After emerging, a queen does not immediately rule. She must first mate. She flies out once, sometimes twice, and mates with multiple drones in midair. This single event provides her with enough genetic material to last her entire life. After that, she never mates again. She returns to the hive and begins laying eggs, sometimes over 2,000 per day. Her presence keeps the hive stable. Her scent tells workers that everything is normal. When that scent weakens, bees react. They prepare replacements. They do not wait until collapse. They anticipate it. Drones exist for one purpose: mating. They do not forage. They do not build. They are supported by the hive until mating season ends. After that, they are pushed out. This is not cruelty. It is survival. Winter is coming. Resources are limited. The hive cannot support bodies that do not contribute. Bees are not emotional. They are efficient. Winter is the hardest test. Bees do not hibernate. They cluster. Thousands of bodies vibrate together to generate heat. They take turns moving from the center to the edges. They eat stored honey carefully. If the winter is too long, or if honey was taken without replacement, the colony starves inches away from food it cannot reach. Many colonies die this way, quietly, frozen, alive until the last moment. Spring brings release. The cluster breaks. Foraging resumes. New larvae fill cells. The cycle restarts, if enough bees survived. This balance is delicate. When humans interfere without understanding, they break timing. Taking too much honey, leaving too little forage, moving hives long distances for crop pollination. Stress accumulates. Commercial pollination has changed bee life. Hives are transported across countries. Almond orchards alone require billions of bees for a few weeks each year. Afterward, those bees are moved again. The constant relocation disrupts their sense of place. Disease spreads more easily. Recovery time disappears. Bees were not designed for endless travel. Still, they work. They pollinate crops that feed millions. They do it despite stress, despite chemicals, despite loss of habitat. This endurance hides danger. People assume bees will always adapt, but adaptation has limits. When queens fail more often, when workers live shorter lives, when navigation errors increase, collapse accelerates. One weak season leads to another. Recovery becomes impossible without help. Help does not mean control. It means removing pressure, leaving flowers uncut, reducing chemicals, allowing wild spaces, letting bees be bees. Bees do not ask humans to manage them perfectly. They ask to be left enough room to function. They have done this job longer than humans have existed. They know what they are doing. Bees sense danger before it is visible. They feel vibration through their legs. Sudden movements, loud impacts, heavy footsteps, all register as threats. A calm environment keeps bees calm. Chaos triggers defense. This is why most stings happen when humans panic, swat, or move fast. To a bee, that motion feels like an attack from a predator many times its size. A bee does not want to sting. For a honeybee, stinging is fatal. The stinger tears from its body, and the bee dies shortly after. This is the last option, not the first. Bees rely on warning signals before that. Guard bees release a scent when they feel danger. Other bees smell it and prepare. If the threat leaves, the response fades. If it stays, the defense escalates. Most people never notice how many times bees choose not to sting. Different bees defend differently. Bumblebees are slower to anger. Many wild bees cannot sting at all. Some simply fly away. Fear often comes from misunderstanding. One bad experience becomes a lifetime reaction. This fear leads to destruction of nests, spraying, and removal. Even when bees pose no real risk, the harm caused by bees is tiny compared to the harm caused to them. When nests are destroyed, local pollination drops immediately. Gardens suffer, trees produce less fruit, wild plants weaken. The effect is rarely traced back to that one moment. Cause and effect drift apart in time. Bees also sense chemical danger. They avoid flowers contaminated with certain toxins when possible. But not all chemicals have warning signs. Some interfere silently. Bees return to poisoned food again and again because nothing tells them to stop. Inside the hive, danger triggers change. More guards appear. Foraging patterns shift. Bees reduce activity to protect larvae. This slows pollination. Stress reduces efficiency. Colonies survive threats by pulling inward, not pushing outward. Humans often interpret this as laziness or failure. It is caution. Bees are sensitive to smell. Flowers evolved scents to attract them. Humans introduced scents to repel pests. Sometimes these signals overlap. Bees become confused. Navigation breaks down. Memory fades. A bee that cannot remember the path home dies alone. Bees navigate using the sun, landmarks, polarized light, and internal clocks. When clouds, pollution, or chemicals interfere, errors increase. The sky itself becomes unreliable. At night, bees rest. The hive quiets. Heat is regulated. Repairs happen. Wax is shaped. Larvae are fed. Even in rest, work continues. Bees do not waste darkness. Human light pollution affects them. Artificial light confuses timing. Night-blooming plants lose pollinators. Day bees become active at the wrong hours. Energy drains faster. Every small change adds friction. Bees also compete, not with aggression, but with efficiency. When resources shrink, weaker colonies fail first. This is natural selection. But when resources disappear everywhere, selection becomes extinction. The sound of a healthy hive is steady, low, alive. Experienced beekeepers know this sound. When it changes, something is wrong. A hive can tell its story without words. Scientists now listen to hives using microphones. Changes in frequency reveal stress, hunger, or queen loss. Bees communicate even when humans are not watching. This constant signaling is why sudden collapse is rare in untouched systems. Collapse happens when signals are ignored or overridden. These never stop responding to the world. The world must decide whether to respond to them. Bees sense danger before it is visible. They feel vibration through their legs. Sudden movements, loud impacts, heavy footsteps all register as threats. A calm environment keeps bees calm. Chaos triggers defense. This is why most stings happen when humans panic, swat, or move fast. To a bee, that motion feels like an attack from a predator many times its size. A bee does not want to sting. For a honeybee, stinging is fatal. The stinger tears from its body, and the bee dies shortly after. This is the last option, not the first. Bees rely on warning signals before that. Guard bees release a scent when they feel danger. Other bees smell it and prepare. If the threat leaves, the response fades. If it stays, the defense escalates. Most people never notice how many times bees choose not to sting. Different bees defend differently. Bumblebees are slower to anger. Many wild bees cannot sting at all. Some simply fly away. Fear often comes from misunderstanding. One bad experience becomes a lifetime reaction. This fear leads to destruction of nests, spraying, and removal, even when bees pose no real risk. The harm caused by bees is tiny compared to the harm caused to them. When nests are destroyed, local pollination drops immediately. Gardens suffer. Trees produce less fruit. Wild plants weaken. The effect is rarely traced back to that one moment. Cause and effect drift apart in time. Bees also sense chemical danger. They avoid flowers contaminated with certain toxins when possible. But not all chemicals have warning signs. Some interfere silently. Bees return to poisoned food again and again because nothing tells them to stop. Inside the hive, danger triggers change. More guards appear. Foraging patterns shift. Bees reduce activity to protect larvae. This slows pollination. Stress reduces efficiency. Colonies survive threats by pulling inward, not pushing outward. Humans often interpret this as laziness or failure. It is caution. Bees are sensitive to smell. Flowers evolved scents to attract them. Humans introduced scents to repel pests. Sometimes these signals overlap. Bees become confused. Navigation breaks down. Memory fades. A bee that cannot remember the path home dies alone. Bees navigate using the sun, landmarks, polarized light, and internal clocks. When clouds, pollution, or chemicals interfere, errors increase. The sky itself becomes unreliable. At night, bees rest. The hive quiets. Heat is regulated. Repairs happen. Wax is shaped. Larvae are fed. Even in rest, work continues. Bees do not waste darkness. Human light pollution affects them. Artificial light confuses timing. Night-blooming plants lose pollinators. Day bees become active at the wrong hours. Energy drains faster. Every small change adds friction. Bees also compete, not with aggression, but with efficiency. When resources shrink, weaker colonies fail first. This is natural selection. But when resources disappear everywhere, selection becomes extinction. The sound of a healthy hive is steady, low, alive. Experienced beekeepers know this sound. When it changes, something is wrong. A hive can tell its story without words. Scientists now listen to hives using microphones. Changes in frequency reveal stress, hunger, or queen loss. Bees communicate even when humans are not watching. This constant signaling is why sudden collapse is rare in untouched systems. Collapse happens when signals are ignored or overridden. Bees never stop responding to the world. The world must decide whether to respond to them. Perfect. I'll do that. I'll create a fully polished, continuous, audio-ready version of the entire book, keeping it documentary style, simple, suspenseful, and fact-based. It will flow smoothly from start to finish with no chapter-like interruptions, no repeated phrases, and perfect pacing for narration. Here's the audio-ready version. Bees are everywhere, yet most people barely notice them. They wake up with the sun, leaving the hive in waves, each bee following memories, scents, and roots learned the day before. They do not wander randomly. Each flower they visit is chosen carefully. They remember which flowers are worth the energy and which paths are safest. Their flight is a map of the environment, constantly updated, constantly revised. When bees land on a flower, their weight and movement release pollen, a process perfected over millions of years. Flowers depend on this contact to reproduce, and bees have evolved to provide it perfectly. Too much force would damage the flower. Too little would do nothing. This partnership shapes landscapes, fields, forests, and gardens. Without bees, plants fail to reproduce efficiently. Seeds weaken. Fruit diminishes. Entire ecosystems begin to unravel quietly. Inside the hive, thousands of bees communicate constantly. They touch, they smell, they exchange chemical signals that tell them about incoming food, danger, the health of the queen, and the condition of larvae. Each bee has a role, changing as they age, from cleaning to feeding to building and guarding, until finally they become foragers. If a hive loses workers, younger bees step up early. If danger increases, more guards appear. There is no waste, no arguing, no indecision. Every movement is for survival. Bees are sensitive to chemicals, to vibration, to temperature. Human pesticides interfere with memory, navigation, and development. Honey contaminated by chemicals carries these effects back to the hive. Larvae grow slower. Queens lay fewer eggs. Worker bees forget the routes to flowers. Colonies appear normal until collapse occurs silently, without warning. Bees do not live alone. They share flowers with flies, beetles, butterflies, and wasps, but their work is consistent and precise. They specialize, returning to the same flowers until pollination is complete. Other insects cannot replace them fully. Different bees work at different times, in different temperatures, with different plants. When one species disappears, the rest cannot compensate entirely, and gaps appear in pollination. This weakens plants, which then affects insects, birds, mammals, and humans. Bees divide labor efficiently. Drones exist to mate with queens. Queens lay thousands of eggs in precise patterns. Worker bees feed larvae, build wax, defend the hive, and forage. The hive survives because each bee responds to signals without hesitation. Stress inside the hive changes behavior. Guards appear when danger is detected. Foraging decreases when food is scarce. The entire system adapts immediately. Bees are sensitive to human activity. Loud movements, sudden actions, or swatting triggers defense. Honeybees sting as a last resort, which often kills them. Most stings happen because humans panic. Many wild bees cannot sting at all. Destroying nests or spraying chemicals harms pollination far more than any sting ever could. Every hive destroyed weakens ecosystems quietly. Bees also interact with microbes. Flowers carry yeast and bacteria, which bees transport, affecting nectar quality and plant health. Honey itself is a map of landscapes, carrying pollen grains from countless flowers. When humans simplify landscapes with monocultures or chemicals, this map shrinks. Bees lose food sources. Wild species disappear. Ecosystems become fragile. Bees navigate using the sun, landmarks, polarized light, and internal clocks. Pollution, artificial light, and chemical interference confuse them. A bee that cannot remember the path home dies alone. Nighttime artificial lights can disrupt activity. Flowers bloom at the wrong times. Foraging efficiency drops. Energy drains faster. Every small change accumulates. Bees survive by repetition and resilience, not perfection. One patch of flowers can feed thousands. Small restored habitats can reconnect fragmented landscapes. Continuity matters more than size. Bees respond fast when humans act kindly, by planting flowers, reducing chemicals, or leaving spaces wild. They do not forgive instantly, but they notice opportunity. The impact of bees on humans is enormous. 1 out of every 3 bites of food exists because of pollination. Fruits, vegetables, nuts, coffee, chocolate, and seeds all rely on bees. Without them, diets shrink, prices rise, and food becomes less nutritious. Honey and propolis have medicinal uses. Bee venom is studied for therapies. Simply observing bees reduces stress and anxiety. They connect humans to the natural rhythm of life. The modern world pressures bees constantly. Habitat loss, pesticides, relocation, disease, and extreme weather all accumulate stress. Colonies may appear healthy until collapse occurs. One weak season leads to another. Survival depends on balance. Humans often ignore the warning signs, assuming bees will adapt. But adaptation has limits. Collapse is often slow and invisible, leaving entire ecosystems and human systems weakened. Bees evolved over millions of years, surviving ice ages and environmental shifts. They are resilient when given a chance. They pollinate in cold weather, heat, wind, and rain. Different species specialize in different conditions. Managed hives, when transported for commercial pollination, face stress and disease, but wild bees are even more vulnerable. Removing habitat, spraying chemicals, or simplifying landscapes creates fragility faster than adaptation can respond. Bees do not act for recognition, profit, or reward. They work constantly. Every flower visited, every larva fed, every hive maintained contributes to life across fields, forests, and cities. They are engineers, laborers, and caretakers of the ecosystem. Humans may forget them, fear them, or destroy them, but bees continue. Their presence is the quiet heartbeat of the planet. The future of bees is directly tied to human choices. If humans act to protect them, plant flowers, restore habitat, reduce chemicals, and allow hives to thrive, bees will continue their work. Ecosystems will stabilize. Food will remain diverse and plentiful. Economies and human health will benefit. If humans ignore bees, ecosystems weaken, crops fail, food scarcity grows, and species vanish. The hum of a bee is the hum of life. The rhythm of their wings is older than humans, older than agriculture, and far older than any city. That rhythm continues only if humans act now, consistently and wisely. Bees are not just insects. They are life, balance, and the quiet power that keeps the world working. If humans choose to listen and protect them, that power will endure for millions of years more.